Welcome everyone. This is our how to find the quadratic equation using the sum and product of its roots. And I know some of you guys are looking forward to seeing this. It'll be helpful to a quiz or just in any math situation where you're given two roots of quadratic equation and trying to find the sum and product. So let's begin with the first question. Find the quadratic equation that has a has the roots of 4 and 9. Well, these are solutions, and so you want to work backwards. There are a lot of quadratic equations that have the roots of 4 and 9. We're going to find one of them, and what we're going to use is a sum and product of the roots. Okay? Now, we will say, what do you mean sum and product? Oh, let's take a look at the sum. Well, the sum of the roots is equal to 4 plus 9, which is 13. And the product of the roots is 4 times 9, which is 36. Okay, well, we have the sum and the product, but how do we use this? For a quadratic equation, the sum of the roots is negative b over a, and the product of the roots is c over a. Now, these a, b, and c values are really associated with the standard form ax squared plus bx plus c. So once we find the sum product of the roots, we find the a, b, c values and plug them into our standard form of a quadratic equation, ax squared plus bx plus c equals 0. Right, so we're going to now use our formulas for the sum product and find our a, b, and c values for the problem we had from before. So we right now say the sum of the roots is equal to negative b over a. And we found that to be 13 over 1. The product of the roots has the formula of c over a. And that's 36 over 1. Now, why write over 1? Well, we're going to write as fractions, and any integer we have can be expressed as a rational number or a fraction, and it's just that number over 1. We will notice, though, that they both have, in both fractions, the same a value, which leads us to the idea that a must equal to 1. Now, let's go with c. C is a little easier because we can associate with that. We see in this case that c is equal to 36. Okay? Now, it's this part here, and we see that negative b is equal to 13. Well, if negative b equals 13, that must mean the positive b equals negative 13. So what we can say in this case is that for the b value, it's the opposite of what we see there. So it would be negative 13. That's the value put in red, so associated with the colors. That's what where students will have difficulty. So you do want to maybe write this part out when dealing with the b value. Okay. Now, does you have to? No, but when you're trying this out for the first time, it really does help. All right, so now what we're going to do is we're going to write out our standard form, ax squared plus bx plus c equals 0. And just fill in the a, b, and c values. We're not filling numbers for x, just fill in the a, b, and c values. So we're going to have, in this case, 1 x squared plus negative 13x plus 36 equals 0. And we'll clean this up, this plus negative 13 as x squared minus 13x plus 36 equals 0. And this is a quadratic equation. And please remember, the equation has equals something, equals 0 in this case. So the quadratic equation, a quadratic equation, not the, because there's more than one that has this though. But so a quadratic equation that has the roots of 4 and 9 will be x squared minus 13x plus 36 equals 0. Okay? So that's how we use this sum product of the roots for this problem. page. Here we have the roots to be 5 over 2 and 8. And we'll see in this case, sometimes we have an equation here. We have fractions in this case for the sum for the roots actually. So the sum of the roots in this case, sum of the roots will be 5 over 2 plus 8. Now, when we add this together, this is going to be, I see now, 5 over 2 is like 2.5, plus 8 is 10.5. Now, 10.5 we need to write as a fraction. Now, 10.5 is really going to be, in this case, 21 over 2. Okay, use your calculator for this. Our product of the roots will be equal to, in this case, 5 over 2 times 8. And that's like 40 over 2, which is the same thing as 20. So 20 over 1. And remember that the sum of the roots is equal to negative b over a, while the product of the roots is c over a. Except, which one's the a value? We have a equals 1, a equals 2. Which one do we use? Well, in that situation, if the sum product roots have different denominators, we need to rewrite the fractions into equivalent fractions so they have the same denominators. This allows us to use the same value for a in both situations. So you're saying, well, what do we mean? Well, the two fractions, and we want them to have matching denominators. They have to be the same value as original. So let's go try these out. So we have here the fraction 21 over 2. And then we have the fraction 20 over 1. So we want to rewrite them so they have the same denominator. Well, the least common denominator in this case, the LCD here, will be 2. So we're going to rewrite 20 over 1 as something over 2. Well, if I multiply 1 times 2, I get 2. So I'll multiply 20 by 2 to get 40. Now we're going to use this case, the sum of the roots is negative b over a, and our product of the roots is still c over a, except now we have an a value that we can use for both of them. They both have an a value of 2 now. So our a value will be 2. They both have a c value, well, this has a c value in this case, of 40. They say, how come not 20? Well, the idea now is that we've modified the fractions to be equivalent to equivalent denominators, to have the same denominator. And so now we can use the numbers that work out for both the sum and product. And again, negative b equals 21. That means our b value has to be negative 21. And we plug into our formula, again, ax squared plus bx plus c equals 0. And so we're going to get, in this case, 2x squared minus 21x plus 40 equals 0. Don't forget to put that equals 0. Now, sometimes we put down equals y or y equals. As long as you have it equal to either the function f of x, y, or you can have it set equal to 0. So this is what we have when we have, here we go, make a full page for you guys to see. This is what happens when you have a situation where you have two roots where one's a fraction and you end up with a sum and product of the roots with different denominators. For our third one, we have these roots with radicals in them, basically binomials and such. We're still doing the same thing. We'll notice that the sum of the roots, and when I add this together, it's going to add downwards. 5 plus the square root of 2 plus 5 minus square root of 2. When you add downwards, well, 5 plus 5 is 10, but these positive square root of 2 and negative square root of 2 cancel out, and there's no more square roots to deal with. With the product of the roots, we have 5 plus square root of 2 times 5 minus square root of 2. They're conjugates, and you will see in this case, when we distribute, we get 5 times 5 is 25. 5 times negative square root of 2 is 5 times negative square root of 2. Square root of 2 times 5 is plus 5 square root of 2. And then square root of 2 times negative square root of 2 is negative square root of 4. Well, first off, this negative square root of 4 becomes just negative 2, and then we have 25 here. And the negative 5 square root of 2 and the positive 5 square root of 2 cancel out, which means the product of the roots is equal to, in this case, 23. So now we have the sum of the roots is negative b over a is equal to 10 over 1. And the product of the roots is c over a equals 23 over 1. Yeah, you're definitely going to have to practice, multiplying, adding irrational numbers. But in this case, it works out nicely because when you multiply conjugates together, there's no more irrationals. While when you add conjugates together, there's no more irrationals. Okay, so we find our a, b, and c values. So we have a equals 1, b equals negative 10, and c equals 23, which means that our quadratic equation that has these roots will be 1x squared minus 10x plus 23 equals 0. Okay? Again, we're just plugging in our values into our quadratic function of ax squared plus bx plus c equals 0. All right, everybody? I hope you found this video helpful. And if you did, please give it a like and make sure if you have not subscribed to the channel, subscribe to our channel. We are running our giveaway of a Line Friends Brown Bear Funko Pop. And so all those subscribed will be entered in. And for the comments, you enter into videos up to, in this case, the end of 2020. Every comment you put in will be an entry to our giveaway. Now you have to be subscribed though. You have to be subscribed to the channel though. Okay. But I hope in this case that you just find this helpful. Please leave questions or comments in the comment section below. Anything you found, like maybe any errors I made, or anything you think differently, maybe a different way of doing things. Or if you would like to see some other more questions being done, please just let me know. I would love to hear from you guys. Okay. All right, everybody. Thanks so much for watching, and I look forward to seeing you again in our next video. Take care and be safe.